Hey guys, it's Ngozi here. Welcome back to my channel. So today I want to be going over solving a problem using dynamic programming. So this is going to be a three-part series where this is going to be the part one of the series. Then subsequently I'm going to upload the part 2 and part 3, so please stay tuned for those ones. For the sake of those who don't understand what dynamic programming is about, DP is a way of solving a problem by breaking it down into smaller problems. That is, solving the solutions to the smallest bit of the problem and using that to go all the way up in order to get the solution to the main problem, and doing this optimally. Personally, I like to see dynamic programming as recursion plus memoization, where memoization is equal to optimization. Memoization means we are saving the result of every recursive call in a cache, such that when we make any call, we check the cache to see if we have the result in it. If we do, we return it, else we go ahead with calling the function again. This reduces the time complexity of the algorithm to a large extent. So for us to be able to do dynamic programming, we have to have a knowledge of recursion because that's the basics of it. And memoization is what makes it dynamic programming. To understand dynamic programming better is better illustrated on a tree. So we're going to illustrate how the recursive calls, or how many recursive calls you're going to have when we're looking for the nth number of a Fibonacci sequence. So we know that a Fibonacci sequence this is a Fibonacci sequence. It starts from 1. So a Fibonacci sequence is a sequence of numbers where a value in its particular position is the sum of the two values before it. So the sum of the two digits before it is equal to that value. So 1 is the first, then you have 1, that is 1 plus 0, then you have 2, which is 1 plus 1, then you have 3, which is 1 plus 2, you have 5, which is 2 plus 3, you have 21, which is 8 plus 13. So the first number in the sequence is 1, the 8th number is 21, the 7th number is 13. So here we have the tree for the 7th number of a Fibonacci sequence. So as we can see, this is basic recursion, and this is recursion with memoization. Now, for us to find the 7th number of a Fibonacci sequence, we have to find the 6th and the 5th numbers. To find the 6th, we have to find the 5th and the 4th. To find the 5th, we have to find the 4th and the 3rd, right? So that's how we have to make all those recursive calls until we get to our base case. So in this case, our base case is going to be 0 and 1. Okay, so what we notice here is that there are a lot of recursive calls just to get the 7th number of a sequence. For example, we can see that 5 is repeating, so we'll have 5 repeating here and here. Let's try to do this. So we can see 5 is repeating here and here. We can see 4 is called 3 times. We can see 3 is called like 5 times. We can see 2 is called a good number of times. So that is what the basic recursion is going to do. It's going to make a lot of calls, irrespective of the fact that that recursive call has been made before. So this makes the time complexity of the algorithm to be very large. So it's going to be like an exponential time complexity. So what memoization is going to do is to eliminate duplicate calls using the same parameter by catching the result of each call, such that when we want to make a call, we first check if that result is already in the cache, right? So for recursion with memoization, we have 7, and we look for 6, and we look for 5 to get 7, right? So for 6, we have already gotten 5, and we have already cached 5, so we're going to get the value for 5 from the cache and use it. So in the end, we see that the big O is going to be an O of n. So as we can see, we're just making, for 7, we're going to make 7 calls, or for recursion, it's going to be a 2 raised to power n. Right, so here. So this is the illustration. I hope this helps you to understand how memoization helps with recursion. So let's jump into the code to illustrate how that works. Okay, so here in the code I have defined the structure for the Fibonacci sequence for the basic recursion and the one with memoization. So what the code is going to be like is simple as fib of n minus 1 plus fib of n minus 2. We're going to return that. That's just basically what Fibonacci sequence is going to do. And what is our base case? So in this case, our base case is going to be when n is less than or equal to 2. In this case, return 1. Okay. So when n is equal to 1, that's the first number of the sequence is 1. When n is equal to 2, the second number of the sequence is also 1. So that is where we're returning 1. That's our base case. But let's see what we're going to have. So as we can see, we have the value for 3, 4, 5, and 9 as 2, 3, 5, and 34. So, but for 100, the 100th number of the sequence, it has not returned, it's still processing. That's because of the large recursive call. So when the input is very large, it's going to take forever to come back. Okay, so the solution to this is memoizing this recursive function. So how do we do that? We use a data structure to hold the values of, it's going to use a hash map. I always like to use a hash map. So we're going to use the hash map to hold the value of each nth number of a sequence. So for each call we make, we're going to save the value in the hash map. It's going to be an integer and a long, and let's call it memo, right? So I'm just going to still copy the same thing because there's no difference. I'm going to copy the same thing, and so but here we're going to have fib with memo. So here we're going to pass back the memo object to the record. So the other thing we're going to do just before our base case is to check for the value in the cache. So what we're going to do is to check if memo contains key, because the n is the number that we're looking for, is the key. So if memo contains key, then please return for us memo dot get n, the same key, right? So it's going to return that back to the caller. Okay, so but here we're going to now return memo dot get n. Okay, and this is where we're going to add the value of each recursive call to our hash map or to our cache. So the key is going to be n, the key is going to be n, and the value is going to be our recursive call. So here basically is the one with memoization. So let's test it with our 100 input. So fib with mem. Okay, so let's declare data structure. So we pass the second parameter, which is the okay. So solution. So let's try to run. Stop and move. Okay, so we can see that the value, the 100th value of the Fibonacci sequence was outputted just in split seconds. So that's the advantage of using the memoized solution. It optimizes the solution to a large extent as against using the basic recursion or the basic recursive solution. This is the part 1 of solving a problem using dynamic programming or memoization. If you found this video helpful, please hit on the like button and the subscribe button, and also watch out for the part 2. Thank you. Bye.